I like this idea of visualizing, basically having like a lightning inside of glass marble. So I kind of really thinking about this sort of representation. Of course, it's more complicated than that. My name is Pasko, and I'm a professor of electrical engineering at Penn State University. So just for general context, usually lightning inside of thunderstorms initiates on a scale of about 100 meters. So it's like a building scale, and a time scale is normally about 1 microsecond. So 1 million, we usually say it's like 1 millionth of a second. So it's very fast phenomena. And potential differences which you need to apply to drive this kind of phenomena in thundercloud environment is about 100 million volts. So there is no analogy exists in experimental setups which we know to reproduce this kind of phenomena. When you work with this kind of material, for example, acrylic, or we also explored quartz because it's a very common material. So we also looked at a material called BGO, bismuth germanite, because this is a material which is very commonly used in X-ray detectors. So we kind of studied these materials. All these materials is about 1,000 times denser than air. So if you kind of compare thundercloud environment and these materials, you have this factor of 1,000. So if in thunderstorms phenomena develops on a scale of about 1 microsecond, in these materials it develops on a scale of 1 nanosecond. If you nanosecond is 1 billionth, so we kind of say that 1 billionth of a second. If in thunderstorms it develops on a scale of 100 meters, in dense material it can develop on a scale of just several centimeters. So it kind of opens a new perspective of looking at lightning research really in a laboratory conditions. Lightning, especially cloud to ground lightning, is kind of a major disruption in our modern electronic world. So the goals there in a lightning research is to understand lightning physics, and with a possible future goal to mitigate lightning. In this particular study which we conducted, so we believe that it may lead to completely new ways of generating X-rays from small volumes and development of principally new X-ray sources. So this may also lead to development of new sources of these extremely high frequency emissions. About 300 years elapsed since that famous Benjamin Franklin experiment when he launched a kite, and he actually saw for the first time that thunderstorms have this electrical nature. So this electrostatic nature of thunderstorms lightning, which was not really known at that time. And he advanced this very beautiful idea, which we use to this day, of lightning rod. So this is kind of remaining one of the primary ways of lightning protection. So we can't really mitigate lightning, but we can use these kind of protection devices, including lightning rod, which was invented by Benjamin Franklin. A lot of research was done on lightning, of course, since then. We learned a lot of information, and we have a lot of new knowledge about lightning propagation and different types of the lightning. Still, we are struggling to understand what initiates lightning. So this is kind of our group is focusing historically on these kind of questions. Lightning, of course, is very difficult to study. So if you can just think about total volume of phenomena, usually you deal with hundreds of cubic kilometers of volume. So a variety of different experimental techniques were used to study lightning. Balloons were sent through thunderstorms just to measure electric fields. Rockets were launched to trigger lightning. Rockets with attached metal wires. High altitude airplanes were used. So these are all very extensive experiments, actually requiring a lot of planning, a lot of resources. If it would be possible to reproduce some of the phenomenology of the lightning in a laboratory setting, that would be a major benefit actually in this research. So beyond these applications I mentioned, so there is a very large community working on plasma science and engineering aspects. Okay, so we're kind of working in geophysical environment, but there is a very large group of people working on applications of electrical gas discharges for environmental purposes, for example, for purification of air. So we really hope that this topic will enter into this community, and additional experiments will be conducted to investigate this phenomena.